MEC351, Chapter 2, Air Psychometric and Air Conditioning Processes. In this chapter, we are going to look into the introduction to air conditioning related to thermal comfort and work productivity. Next, dry and atmospheric air, specific and relative humidity of air, enthalpy of air, dew point temperature, adiabatic saturation and wet bulb temperature. Subchapter 2.2 until 2.6 is the introduction towards the properties of air. Next, in subchapter 2.7, we are going to look into the psychometric chart. In subchapter 2.8, our discussion will be on air conditioning processes, which includes simple heating and cooling, heating with humidification, cooling with dehumidification, and adiabatic mixing of air streams. By the end of this chapter, please ensure that you are able to understand the role of air conditioning process in our daily life. You are able to differentiate between dry air and atmospheric air, define and calculate specific and relative humidity of atmospheric air, able to calculate the dew point temperature, able to relate the adiabatic saturation temperature and wet bulb temperatures of atmospheric air, able to use the psychometric chart as a tool to determine the properties of atmospheric air, and able to apply the principles of the conservation of mass and energy to various air conditioning processes. Subchapter 2.1 Introduction to Air Conditioning. Air conditioning, or AC, is the process of treating air in an internal environment to establish and maintain the required standards of temperature, humidity, cleanliness, and motion to improve the comfort of occupants, or we call it as human comfort. Why do we need to improve the comfort of occupants? The human body, just like ourselves, can be regarded as a heat engine, where heat will be produced. The heat will be produced depending on the level of activity that is being done. This heat must be rejected to ensure the human comfort. Examples for rate of heat generation that depends on the level of activity are shown in this table. As you can see, there are 3 different activities listed in this table: sleeping, office work, and heavy work. Different activities will produce different heat rate, and also the heat that is being generated or produced is different for different gender for the same activity. In order to reach thermal comfort, let's first understand the term thermal comfort itself. Thermal comfort can be defined as the condition when the human mind expresses satisfaction with the thermal environment. Note that for different persons, they might have different preferences for the thermal environment that they are feel comfortable with. Thus, we need to have some guidelines or standards for us to get the range that can be defined as human comfort. For example, the temperature within the range of 22 degrees Celsius up until 27 degrees Celsius is the range that can give human comfort to the occupants. The relative humidity, RH, should be in between 50 to 55. Air motion 0.15 up until 0.25 meter per second, and air cleanliness also is a part that plays a role for the human comfort. One of the standards that we can use is Malaysian Standard MS 1525-2007 Code of Practice on energy efficiency and use of renewable energy for non-residential buildings. In these documents, it states that for the purpose of engineering design, room comfort condition should consider the following three main factors. They are dry bulb temperature, relative humidity, and air movement or air velocity. The reason why we want to have thermal comfort is because we want to maintain the human body temperature at 37 degrees Celsius. If the dry bulb temperature is too high, the occupants will feel hot, while if it is too cool, also will not comfort the occupants. If the relative humidity is high, the amount of heat that the human body will able to transfer will be lower by means of perspiration. The dry bulb temperature should be in range of 22 degrees Celsius to 27 degrees Celsius as stated in MEC351. This is the general items that we need to consider when we want to design an air conditioning system. This is because thermal comfort can affect the work productivity of the occupants. If the condition reach thermal comfort, it can increase the work performance. It can decrease the negligence. We are going to have few absentees, and it might improve the morale of the occupants. Beside the occupants, air conditioning system is also used to provide comfortable conditions to suit some processes. For example, computer room or server rooms and medical facilities. This area requires certain air temperatures and humidity for a success operations.